Welcome to AutoSens, the world's leading community for ADAS and autonomous vehicle technology development. We create best-in-class events, training, and information for the purpose of connecting the global community of engineers, scientists, and other automotive industry experts. We are joined by a longtime member of the AutoSens family, Matt Daley, Technical Director at rFpro. Matt, welcome back and good to see you again.
Yeah, fantastic, Carlos. Great to see you, and we're looking forward to seeing you in person in Detroit very soon.
Yeah, indeed. Matt, give us an overview of rFpro. There's a lot of great history with the company. Give us an overview of what you're doing.
Fantastic, thank you. Yeah, so rFpro is a simulation company that um, concentrates on driving simulation, and we're here to really help our customers develop their vehicles, whether they're classic automotive work, vehicle dynamics, and obviously most relevant to AutoSens in the ADAS and the autonomous driving space, where we can help customers develop high fidelity synthetic training data to train machine learning systems, as well as really high fidelity testing data that people can either run on software in the loop systems or can record for playback into hardware in the loop systems as well.
Matt, we have talked about ray tracing in the past. There are some exciting new updates there for ray tracing. So take us through that and tell us the latest there.
Yeah, fantastic. So as always, nothing is ever fully developed, and we're continuing to push the technology that we released last year. We've had a lot of continued work with Sony, as you can imagine, integrating their CMOS sensor, the IMX, into our ray tracer, and that's helped us really look at a lot of the correlation of nighttime and complex daytime conditions, which has been really interesting. But we've also been thinking about the world outside and the atmosphere, and how can we create more of those really challenging driving conditions that and the edge cases that we have to deal with. Fog is always such a really tricky thing, and lack of vision. And so, yeah, we've been adding things like our volumetric fog, our volumetric scattering into the ray tracer, and it's having really marked effects at helping take what is probably a very easy to deal with scenario, and then suddenly you turn on a foggy morning, and this is where safety becomes critical. And we can't rely on just making beautiful pictures in the daytime or nighttime. We have to make images and sensor outputs that really deal with those safety critical edge cases.
Matt, just looking at your background, talking about the fog and talking about these updates, these important updates in ray tracing, it has to be more than just cameras, though. So how do we make margin, if you will, for, say, like LiDAR and radar to join in?
Yeah, it's always a big challenge because, especially to talk about it, it's very easy for us as humans to think about cameras, and they're similar in the way that they see the world to how we do. At least they're using the same part of the electromagnetic spectrum. So we're all using light, and it's between our 400 to 700 nanometers. So the material properties in that wavelength are very well known and are very well established in the rendering industry and the 3D modeling industry. The real challenges come when you're jumping a little bit of distance into the infrared range for lasers and LiDAR, and even more so when you take that huge leap across the electromagnetic spectrum up to the radar and the millimeter wavelength parts of the spectrum. So it's a big challenge because if you think about, as we said, historical rendering and 3D modeling, we're just not used to defining those material properties for radars in such a detailed way. And so what we've done is actually started to separate the idea of what are materials and what are material properties, because we can always define what is the material that is inside a model or that a sensor is looking at, even if we as a modeling company don't know the exact material property that a 77 gigahertz radar is going to need. So what we've been looking at and building into our models in the past 6 months is what we're calling our physical material description. So what that fundamentally means is when a sensor model and it could be a LiDAR or radar or a camera, is firing their rays around and exploring the scene, they can ask for what the material itself is. So that could be, I've found a lamppost. The exact material here is mild steel, and it's painted and it's red, and it's a gloss finish of paint. So that doesn't change depending on the sensor that's looking at it. So we separate, and that becomes a PMD, a physical material ID, which allows the even cleverer people than us that know about specific material properties for the radar to develop external tables and scale those tables and expand the range of the simulation based off the different sensor modalities. So yeah, what we're really doing there is trying to keep this idea of a single simulation and a single set of models that can be applied across so many different types of sensors that are needed inside autonomous vehicles.
Matt, this is really fascinating stuff. This is why I always enjoy talking to you. I always enjoy getting caught up with you when we have this opportunity for AutoSense. Speaking with Matt Daley, Technical Director at rFpro. Matt, you're also doing some work now with ASAM.
Mm.
Tell us more about what's going on there. Give us the latest.
Yeah, Kyle, it's very much linked to what we've just been talking about. So ASAM has always been a leader in the industry in trying to help define standards and interfaces so that simulations can be reused and exchanged where possible. So Open Drive has been around for a long time, which is how we describe the shape of the roads and the network that's there. And more recently, you've had the whole development of Open Scenario, which is how you define where the vehicles and pedestrians should be going inside a test. But what's always been a little bit missing is this idea of, okay, how do the sensors see the world? And how do we get these material definitions that are standard and allow us to really bring in different types of sensors? So yeah, we've been really proud to join ASAM's new Open Material project, which is kicked off beginning of this year, beginning of 2024. It's actually meant we've joined ASAM as an organization for the first time, which is fantastic. And yeah, being involved in that project and getting to work with the teams from BMW, from Volvo, and our other industry simulation companies that are also in there as well. It's a great collaborative effort, and I think it's a really good example of where this big challenge, as we always talk about material definitions inside simulations, we are actually trying to attack that as a group now and as a collaborative way of working, which I'm really pleased about, and hopefully means that we all don't come up with slightly different solutions and we all spend our time implementing slightly different things when, yeah, we can benefit each other.
Matt, in addition to the work with ASAM, you also have some other collaborative projects that are running right now. Tell us more about that.
Yeah, again, it's all sort of linked, and one of them is very much linked around this idea of material definitions and sensor modeling. So um, we've been working with a group on the Sim for CamSense project, which is part of the Innovate UK's supply chain project, kicked off last year. It's led by our long-term partner Claytex, who are also at the event, and I think actually giving a talk about our Sim for CamSense project, which is great. And that's really concentrating on how do we, as a group of partners, help to validate that the simulation that we're doing is high quality. And it's really important because we talk about this every single time. Simulation is great, but it's only as good as your correlation and how much you believe in it. And so the Sim for CamSense project is putting a huge amount of effort and thought behind how do we go and test sensors in physical conditions. Some of them exterior, outdoor, where we're trying to measure how they react in fog, in rain, and in snow. And then some in very good, tightly controlled laboratory conditions where radars and LiDARs might be looking at different materials that are on top of pedestrians, for instance. And it's a great collaborative project of Claytex, as I said, as the lead, ourselves looking at simulation and the simulation platform, and then our academic and measurement partners such as WMG, Warwick University, the NPL, which is the National Physical Laboratory here in the UK, um, a catapult, the semiconductor catapult as well. And I'm hoping I haven't left anybody off the list, but I'm sure there is one or two. So that's a great project, and as I say, that's really concentrating on the scientific measurement of sensors and sensors in different conditions. And we have a lovely complementary one to that, Deep Safe project, which is led by another long-term partner of ours, D-Risk, and that's really looking at how can we get real-world measurements from more dynamic actual edge case data. So how do we collect some really interesting motion data for multiple types of sensors that are in near crash scenarios, and then go and reproduce that data and again do the whole correlation exercise to prove how close are we getting in simulation, where can we improve that simulation to get us closer, and then hopefully by the end of the project also show that, well, that data is now good enough to take a machine learning system and retrain it with the simulation in that crash test to improve the system's performance in how it's identifying the critical objects in that safety critical edge case.
Matt, it's always a pleasure. Again, like I said, it's always a pleasure to talk with you and have you part of our AutoSens events. I always appreciate your insight and sharing your thought leadership. Matt Daley, Technical Director at rFpro. Matt, thank you for being with us today. We'll look forward to seeing you in Detroit here real soon.
Great. Thanks, Colin.
For more information on rFpro and to find out more about our upcoming events, see the links in the description. Visit auto-sense.com. That's auto-sense.com. And for more in-depth interviews like this, subscribe to our YouTube channel and follow AutoSense on LinkedIn. In Detroit, on behalf of AutoSense, I'm Carl Anthony.